Welcome to our demo of the Hedvig distributed storage platform in hybrid and multi-cloud architectures. Today we'll look at how Hedvig overcomes the rigidity of traditional storage to provide a single programmable data management layer that spans across storage tiers, workloads, and clouds. Hedvig software-defined storage runs on commodity servers and cloud instances to help you access and protect applications and data among a global footprint of private and public cloud sites. Over the next few minutes, we'll look at how this works. Let's start with a hybrid cloud architecture. As shown here, what we mean by this is that Hedvig software-defined storage nodes are located in both a private data center and a public cloud. In this case, the cloud being Amazon AWS, utilizing EC2 compute instances. Today we'll look at a dual cloud deployment, but with Hedvig this can easily extend to 3 or more sites, as highlighted here. Looking inside the Hedvig web UI, we see that we have half of our nodes, 3 servers, in AWS, and the other half in our data center, SNC3. Let's inspect the AWS part of the solution. If we look in the Amazon EC2 management dashboard, we'll see the nodes, Storage 4, Storage 5, and Storage 6. What we can do is log into each of these live nodes, and we can see the private IPs here in the lower part of the screen. We have 172.3.1.7.41 and 4.2, and our third AWS node is .43. Now let's provision a virtual disk and see how we select a policy that directs data to both data centers on and off-prem. Hedvig lets you choose at a granular level the characteristics for the virtual disk, not just name and not just size, but also the protocol to use and a range of features including replication and specifically where to store copies. Here we'll distribute copies of our virtual disk in both our SNC3 data center and AWS. If we had more than 2, we would see additional sites in the dropdown, and we can just choose based on where we want the data to live. Once we hit run, that disk is created and ready to go. Now, because we haven't written any data to it, it really only exists in metadata at this point. For our next step, so we can actually see that the data is being stored in both our on-prem data center and AWS, we'll actually format and use the disk so we can see how it works. Step 1 in that process, as with any disk, you have to provide access to a host that will use it. We do that here by adding the LUN to our Hedvig storage proxy. And then we pick our host that will use our virtual disk via that proxy. We'll log out and then back into our iSCSI portal to force a rescan so we can see our list of volumes. Here you can see that they are all residing on Hedvig software-defined storage. We're going to work with the one I just created. This is LUN 3. Back in the Hedvig console, let's click into the proxy that is providing access to our virtual disks, and on the left we have our activity meter for hybrid disk 5. Let's drop back into our Linux host and prepare this volume for use, including creating a partition and formatting it. In the Hedvig console, we see the activity starting, so let's go back and inspect the properties of our virtual disk. There are now containers in our data center and in AWS. Data will be distributed across these nodes with copies in each location. If you look at the location field, you can see what nodes are being utilized. From here, we can use the volume, and here we create and mount a directory. Look at the details, and even copy some data into it. All fully active and available in both locations, our private data center / cloud and our public cloud data center. You can also leverage Hedvig as a data management solution within multiple public clouds. Today we'll look at a setup with AWS and Microsoft Azure, but this can also extend even beyond 2 sites, for instance, adding a 3rd site such as the Google Cloud Platform. Why would you do this? Well, many organizations today are born in the public cloud and want to leverage a mix of providers to get the best price and the best performance depending on what types of solutions they're running and where they need those solutions to be. With Hedvig, you can natively replicate data among clouds to provide data locality and availability. This lets you do things like automatically move applications and services anywhere globally based on business policies. All of this without incurring the delay and penalty of moving terabytes or petabytes of data among cloud providers. In this setup, Hedvig software is installed and running in both AWS as well as Microsoft Azure. In contrast with the former setup, here we have all of the storage nodes that make up this cluster in the public cloud. 3 nodes in AWS and 3 nodes in Azure. Like the first part of this demo, we can look into AWS and see our provisioned compute instances, Storage 1, Storage 2, and Storage 3. Let's jump over to Azure. Here we can also look at our nodes, Azure Storage 3, 2, and 1. We can click into each one of these instances and see how this looks from within the Azure dashboard. Lots of charts and details to give us an idea of how things are running. Like we did in the hybrid section, let's provision a virtual disk. We'll choose our name, and let's do a 100 gig block disk. Because we give you the control over what data goes where for individual virtual disks, in a multi-cloud deployment, you can choose what data gets put in what location. It may be one site, it may be distributed to a second site as well, or a third or a fourth, depending on your footprint of cloud locations. Here we again select data center aware in our replication policy, and as we just saw, these data centers are actually public cloud data centers within which we're running the Hedvig software. When we hit run, the virtual disk is created. Now, like in the first part of our demo, now we want to actually use the disk. We have to provide host access, so let's do that here quickly. Inside the Windows iSCSI Initiator Properties screen, when we hit refresh, we'll see our new disk target, and we'll connect to it using the iSCSI IQN. To use the virtual disk with Windows, we then use the disk management console to bring the disk online and initialize it. Now that we've done that, we'll see some Hedvig containers created, one on an instance in Amazon and one on Azure. We can see that our drive is online, but we haven't formatted it yet, and if we look in Windows Explorer, we don't yet have a drive letter associated with it. Now let's choose a drive letter and format the volume. Once this is complete, first of all, we see our drive letter, and now we can start using it. Let's create a simple text file. Meanwhile, back in our virtual disk details, we can see that Hedvig is now distributing data across nodes in our 2 clouds. In fact, we now have 2 new containers that are hosting data for this volume. That concludes our demo. If you're looking for a storage solution, check out Hedvig. It's designed from the beginning as a modern distributed storage platform that can help you manage data across any workload, any cloud, and any storage tier to help you reduce storage costs, but also to help you increase agility and ensure your data is stored, protected, and available. Thank you for watching. To learn more, visit hedviginc.com.